Okay, well, let's talk a little bit about control transformers. You'll be doing some skills using a simple transformer. We've already seen that you'll be using what's commonly called a primary and secondary winding. But when you get out into the real world, most transformers you will be encountering as far as control transformers, from dropping down our high three-phase voltage to a lower voltage that we can use in our panels, will be multi-tap. That's because manufacturers do not want to create separate transformers for different voltages. So they add taps that we can configure our control transformer to drop, say, 480 down to 120 volts AC, or we can configure it to drop 220 volts down to 110 volts AC. So pretty much all of them will have a diagram on the front of them, okay? Now, if we have problems with our transformer, as in blowing fuses, it may not be a load problem. We could have a bad transformer. They do go bad. So how do we test them? Well, I have this virtual one up. It will work for our purposes. I believe this one's actually a center tap in your book, but we're going to pretend it's not, and we should get the same readings. So here we have our primary and our secondary. Notice that it has two configurations. We have one for 240 volts and one for 480 volts, etc., etc. Look at our coil configurations. Do you see that in the high voltage configuration that H2 and H3 are tied together? So let's examine this. It shows power coming in H1, and if we follow H1 on our diagram, we'll see that it goes to H2. Here's our jumper, so it's going to come through here. So it's basically a one long coil. We're jumpering right here, so we basically have one primary winding and one secondary winding. And that will reduce the voltage from 480 volts to 110 volts. Now, if we want to use a lower voltage here, notice the configuration jumpers are different. We have H1 to H3 and H2 to H4 jumper. Okay? And so if we look at that, we'll see that H1 and H3 here will be jumpered. And if we follow that out, we'll see that we actually have a series parallel combination of windings. So now we actually have two primary windings hooked in a parallel configuration to drop it to 110 volts. So how do I test this? How do I know if this transformer is bad? I don't know what it's supposed to be. Well, most of the time you can generally tell by checking each winding to ground if the transformer is disconnected, but there should be a balance. The winding on this side is exactly the same as this side. So if they're not balanced, they do not have the same ohm reading, then more than likely you have an issue. So here we have our virtual meter, and it's set for 200 ohms, and I'm checking the secondary winding of this control transformer, and I see that it's stable at 3 ohms. So let me check. We don't know which one's on here, but we do know it's H1, H3, H2, that if we start from the bottom, that 2 and 4 should be one set of coils. And so let's check here and check here. And so now I'm checking from H1 to H2, and I'm reading 8.5 ohms. Okay, now let's look and do the opposite check here, H3 to H4. So we're going to come over here, and I'll see that I have 8.8 ohms, which is pretty close. If you have a point, I would say a 0.5 ohm variance, don't worry about it. Okay, and we should also check the ground. I actually have a bad transformer we're going to look at, which will give us a clearer view of what a real world transformer is, but we were looking for a resistance balance in these coils. That doesn't always tell you, because you could have a partial short in your secondary and you wouldn't know what that value was unless you hooked it up and you check the voltage, because that's another check. You can check the voltage coming out of it. If it's hooked up correctly, you should be reading 120 volts, however the configuration is. If you're not reading 120 volts with the fuse pulled, then it's a good bet that something's wrong with your control transformer. So that's a good thing to check. But let's look at a real one that is damaged. All right. So let's examine an actual control transformer. This one's bad. If we look here, we'll see some screws. This is our secondary. These screws here are just ground screws. If we actually look inside there, we can see that they are not connected. Here we can see a soldered connection to our secondary coil right here. See the little wire that is soldered on there? If I look on the other side, which is our primary, and I look here, I can see a soldered wire here, 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 and here inside this coil. So let's go back to testing. We're going to flip this back up. We'll put a little diagram on here. And probably more than likely, you set your meter to 200 ohms will be perfectly fine, which is what I've done. Let's see if we can get them both in there. Okay, unlike the simulator, in real life, remember this is one coil of wire. Your meter, when it is checking resistance, is putting out voltage. So if we have a coil of wire and we apply a little electricity to it, it's going to charge up, which means that we're going to have to wait for our meter readings to stabilize to get an accurate reading. So you can't always just check it right away. So we're going to come over here and we're going to check our secondary. Notice that it begins to change as I charge the coil up. I'm going to hold a hard, steady pressure. Eventually, it will stabilize pretty close. So we're looking somewhere around 5 ohms on our secondary. Now I want to check this to ground. So I'm going to come over here and make sure it's not shorted to the frame anywhere. Try to find a piece of metal. Don't want to do it on the paint. And so, because I know there's continuity, I know this coil is good because I'm reading something. Reading something right there. Now, on my secondary, the taps have been removed. Our jumper configurations, you want to always have that. So if you're when in doubt, you can simply take the screw, disconnect the power, lock it out, pull the little taps off, little metal jumpers here, and test it that way. So we're going to look at one coil here. And so it's showing H1 and H2. So let's check H1, which is here. And let's follow it around to H2, which is the third one. See if we can get a little better view here. Perhaps. So we're going to be checking H1 to H2. This is one coil. I'm going to hold my meter steady until it stabilizes. Notice it's fluctuating quite a bit. Eventually it comes to rest around 4.2 to 4.3 ohms for one side of the coil. So now I'm going to check the other side, which is 2 over. We're checking H3 to H4. And as I wait for it to stabilize, I see that it has settled at 1.3 ohms, which tells me, if I check the ground, I don't see anything that tells me that H3 and H4, somewhere in this coil of wire is a short, and so it's actually jumped somewhere inside there. Because of the imbalance, I have less resistance, which tells me that somewhere on this H3 and H4 got these coil of wire shorted. And so if I look at that, I'll see there's a jumper here. That means that part of this coil is null and void because it's a jumper. There's a short inside this transformer, which means it is no good and it's time to recycle it. So that would be a pretty good lesson. Most of your transformers you see are going to be in this dual voltage configuration, so pay particular attention to that when hooking it up. If you hook it up incorrectly, you will blow up stuff. All right? If you hook 220 to a 480, you're not going to get the right voltage, and whatever's coming out is going to be incorrect. So make sure you can even, if you hook it up wrong, that's fine. Just don't have anything connected to the secondary. So have it, and you can check the voltage on the secondary before applying it to the rest of the circuit.